Our third lesson in the Points, Line, and Planes unit is titled Segments and Their Measures. We're going to be looking at line segments, and we're going to be finding the length of those line segments, or the distance between two coordinate points. Our essential question is, how do I find the lengths of segments? We've already learned one method of finding the lengths of segments. We learned the distance formula in the last lesson. Today, we've got several vocabulary words. We're going to begin with the word postulate. Rules that are accepted without proof are called postulates. Depending on where you go to school, you might see them called axioms. I know in British schools they're called axioms. My college textbook generally called them axioms. So it all depends on who wrote the textbook and where you are. But a postulate and an axiom are the same thing. Another vocabulary word today is a coordinate. That's any real number that corresponds to a point on a line. So let's sketch a quick number line here. If I ask you for the coordinate of the red dot, you would tell me -1. Coordinate. Distance. We learned the distance formula last class, but this is the definition of distance. The distance between any 2 points on a line. So I'm going to say, let's draw a line. We're going to have A and B. So the distance between A and B, remember there's no bar when we're talking about a measurement, is the absolute value of the difference between the coordinates. Now, why is it absolute value? Okay, distance has to be a positive value, and if I subtract A, if I do A minus B, the way I wrote it in this example, I would end up with a negative value. Okay, so I need to make that positive. If I do B minus A, my answer will come out positive anyway. So the absolute value takes care of the subtraction. You can do that in any order and still get a positive distance. Length. The length of a segment is the distance between its endpoints. So we can ask you to find the distance between 2 points or the length of a segment, different ways to ask the same question. Between. This idea of being between is important mathematically. When 3 points lie on a line, you can say one of them is between the other 2. So let's put 3 points on a line. Which point is between the other 2? In this case, point B. Congruent is exactly the same. We talked about congruent in the first lesson. The symbol is the equal to sign with a tilde on top. Exactly the same structure or shape and exactly the same size. Congruent segments are segments that have the same length. Alrighty. So we have a postulate that we need to know, and it is titled the ruler postulate. The ruler postulate says all of the points on a line can be matched 1-to-1 with real numbers. Remember that real numbers include fractions and decimals. Don't think it has to be an integer. Remember that the real number that corresponds to a point is called the coordinate. And then the distance form, or the ruler postulate, says the distance between points A and B, written as length AB, is the absolute value of the difference between the coordinates. That's that formula from our definition on the front right here. AB without a bar is called the length of segment AB. The ruler postulate is what makes a ruler work, okay, what allows us to measure things with a ruler. So as we look at my example here, what kind of a ruler is this? It's a centimeter ruler, okay? So the length of segment AB is about 3.5 centimeters. When you have units for your problem, you should include units in your answer. So let's look at this using the formula. The length of AB is the absolute value. The coordinate for A is 1, minus the coordinate for B is 4.5, which would be the absolute value of negative 3.5, which is positive 3.5. Seems easy and obvious because we used it in elementary school all the time. If we're finding the distance between A and B, in elementary school, the very first thing we learned to do was to count it. 1, 2, 3, 4, 5. Then we learned to subtract using the number on the right first minus the number on the left. Of course, our ruler postulate says the order doesn't matter because we have absolute value, which allows us to get the same length or distance either way. One of the most important concepts in this unit comes up right here, the segment addition postulate. You have been using this idea since elementary school when you added fractions, when you added decimals. Let's look at a pan of brownies. If I cut myself an extremely large piece, the part I cut plus the part remaining equals the whole pan of brownies. And this is what we're talking about today. The part plus the part equals the whole. So if point B is between A and C, then the part of this segment plus another part of the segment will equal the entire segment. This only works when you have one point between another two. So the part plus the part equals the whole is important. Let's look at this idea of being between or betweenness, as you will see it written in a math textbook. Go ahead and try to draw those next two diagrams for me. Pause your video. All right, in the first diagram, E needs to be between A and C. I put E closer to A. You could have put E closer to C. I did not put E in the middle because they didn't tell me it was a midpoint. All right, so I didn't want it to look like it was in the middle. For the second one, I put E to the left of A, but you could have put E to the right of C. Either one would be correct. Let's look at this problem here. Looks like I'm using the same diagram for both 1 and 2. So I'm going to just sketch it, nothing fancy, so that I can label it. If AB is 12 and BC is 5, what is AC? Well, the part plus the part equals the whole, and the length of AC would be 17. Redrawing my sketch. If AC is 20 and BC is 4, what is the length of AB? So the part plus the part equals the whole. the length of AB will equal 16 in this one. So when you're asked to write the segment addition postulate, that means write out the part plus the part equals the whole in symbols. In this case, I have the length of AB plus the length of BC equals the length of AC. All right, so in this diagram, I've got 6 questions, but we're using the same values for all 6. So I'm just going to draw on the diagram itself. Now, it says GK is 24. So this whole thing, let me go up a little bit, is 24. Then it says HJ is 10. GH equals HI equals IJ. What does that mean? You are correct. That means that each of these segments have the same length and they are congruent to each other. The way it's written is same length, and if we have segments with the same length, then you have congruent segments. So I think at this point I have enough information to figure this out. If HJ is 10, what would we call point I as we just look at HJ? I is a midpoint. I is splitting this length of 10 in half, so each of these pieces is 5, and since GH is the same length as HI, it is also 5. Okay, now from G to J, I've accounted for 15 out of my whole, which is 24, so JK has to be 9. Now that I've completely labeled that diagram, let's fill in our answers here. The length of HI is 5. The length of IJ is 5. The length of GH is 5. The length of JK is 9. What have we got next? The length of IG. So from G to I, that's 10. And the length of IK, 5 plus 9 is 14. If you're doing geometry without labeling your diagrams, you're doing geometry wrong. We want to see the diagrams labeled on every problem. Ooh, algebra. Suppose J is between H and K. Did they give me a diagram? No, those dirty dogs. I've got to draw my own. All right, suppose J is between H and K. Use the segment addition postulate to solve for X, then find the length of each segment. So let's label this. HJ is 8X, JK is 4X, and KH is 72. So the part plus the part equals the whole. 8X plus 4X equals 72. 12X equals 72. X equals 6. Now to find the length of each segment, I'm just going to substitute my X value back into what I was given. So the length of HJ will be 8 times 6, 48. The length of JK would be 4 times 6, 24. And I already know the length of KH. There's no need to write that again. All right, I want you to try these two on your own. Pause your video and come back to check when you're done. All right. Number 2 is a challenge. Number 2 is a challenge because you got a fractional value for X, 21/5. So even I had to do a little scratch work to the side to figure out HJ and JK. So in the first step here, let's look at JK, right? I substituted. Then I multiplied the 3 times 21/5 to get 63/5. And I went ahead and converted the whole number 3 into 15/5 so that I had common denominators and I could subtract. I did the same thing in HJ. And then I checked my work. 62 plus 48 is 110. 110 divided by 5 will give me 22 for the length of KH. Fractions are your friend. Don't be afraid of the fractions. Number 3 was a little easier because x came out as a very pretty whole number, making it much easier to substitute in and solve for the length of HJ and the length of KH. So take a minute and write a summary. Make sure you include the segment addition postulate and the appropriate vocabulary in your summary.